Hello friends, now we discuss what is the linear differential equation with constant coefficient. So we take an equation of the form dny by dxn plus p1 dn minus y by dxn minus 1 plus p2 dn minus 2y by dxn minus 2 and so on pn y is equal to q. Where p1, p2, p3 and so on pn are constants and q be a function of x or constant, then this equation, this differential equation 1, this differential equation 1 is said to be linear differential equation with constant coefficients. With constant coefficients. Here you can see an equation of the form dny by dxn plus p1 dn minus 1 y by dxn minus 1 plus p2 dn minus 2 y by dxn minus 2 and so on pn y is equal to q, where p1, p2, p3 and so on pn, all these are constant and q be either a function of x or constant. Then this differential equation 1 is said to be linear differential equation with constant coefficient. Now consider q is equal to 0, then above equation reduces to dny by dxn plus p1 dn minus y by dxn minus 1 plus p2 dn minus 2y by dxn minus 2 and so on pn y is equal to 0. Let here we put q is equal to 0 in above equation 1, we get the second equation. Let y is equal to e to the power mx be the solution of equation second. Then we find the derivative of y with respect to n. We get, if we find derivative of y with respect to x n times, we get d by dn of e to the power mx. We get here m to the power n e to the power mx. You can see here if we differentiate y n times with respect to x, we get m to the power n e to the power mx. Similarly, if we differentiate y with respect to x n times, we get here m to the power n minus 1 multiplied by e to the power mx. Similarly, if we differentiate y n minus 2 times with respect to x, we get here m to the power n minus 2 e to the power mx and so on. You can see here, first we suppose that y is equal to e to the power mx be the solution of this equation second. If we substitute e to the power mx in place of y, we get, if we substitute e to the power mx in place of y, we get, if we put value of y in, if we put y equal to e to the power mx in equation second, we get m to the power n e to the power mx plus p1 m to the power n minus 1 e to the power mx plus p2 m to the power n minus 2 e to the power mx plus and so on pn e to the power mx is equal to 0. Now we taking common e to the power mx. So we get here m to the power n plus p1 m to the power n minus 1 plus p2 m to the power n minus 2 plus and so on pn e to the power mx. You can see e to the power mx can never be 0. So m to the power n plus p1 m to the power n minus 1 plus p2 m to the power n minus 2 and so on pn is equal to 0. Suppose this is the third equation. Third is called the auxiliary equation. Equation third is called the auxiliary equation. If m1, m2 and so on mn be the n different roots of third, then e to the power m1x, e to the power m2x and so on e to the power mnx be also different roots and linearly independent. So the general solution of second is y is equal to c1 e to the power m1x plus c2 e to the power m2x plus c3 e to the power m3x and so on cn e to the power mnx. You can see that this is the solution if the roots of the auxiliary equation are distinct, and the solution e to the power m1x, e to the power m2x and e to the power mnx, these all are distinct or different roots and these are linearly independent. So the general solution of second can be written as y is equal to c1 times e to the power m1x plus c2 times e to the power m2x plus c3 times e to the power m3x and so on. Now we take some example on this article. You can see this example here. This is the third order linear differential equation with constant coefficient. You can see that here the coefficient of d2y by dx2 is 6, which is constant. Coefficient of dy by dx is 11, which is constant, and coefficient of y is 6, which is also constant. And the right hand side is 0 here. So you can see this is the third order linear differential equation. This is third order linear differential equation. You can see here this is third order linear differential equation with constant coefficient. So first we write this. This can be written as d cube y plus 6d square y plus 11 dy plus 6y is equal to 0, where capital D is equal to d by dx. This can be also written as d cube plus 6d square plus 11d plus 6y is equal to 0. This is the third order linear differential equation with constant coefficient. Third order linear differential equation with constant coefficients. With constant coefficients. Now for solving this, first we find auxiliary equation. For finding the auxiliary equation, in short notation we can write it auxiliary equation A dot T. We put m in place of capital D. We get here m cube plus 6m square plus 11m plus 6 equal to 0. For finding the auxiliary equation, we put m in place of capital D. So here this is m cube plus 6m square plus 11m plus 6. This is the auxiliary equation. Now we solving this equation and get the roots of this cubic equation. So if we put here m is equal to minus 1. If we put here m is equal to minus 1, put m is equal to minus 1, we get minus 1 cube plus 6 minus 1 square plus 11 minus 1 plus 6. You can see here this is minus 1 and this is plus 6 minus 11 plus 6. This is 12 minus 12, this is 0. So m plus 1 is a factor of above cubic equation. So first we you can see that here we find auxiliary equation. For finding the auxiliary equation we put m in place of capital D. So here m cube plus 6m square plus 11m plus 6 equal to 0. Now we put m is equal to minus 1, we get the value of this polynomial is 0. So m plus 1 is a factor of above cubic equation. So m plus 1 is the factor. So we write here m plus 1 3 times. Now you can see here we find m cube. If we multiply m by m square, we get m cube. So we write here m square. M square multiplied by m, we get m cube. M square multiplied by plus 1, we get m square. And here we have to find 6m square. So 5m square is less. So we put here 5m. If we multiply this 5m by m, we get 5m square. And m square multiplied by plus 1, we get m square. So m square plus 5m square, we get 6m square. Now this plus 5m multiplied by plus 1, we get 5m. So 6m is remaining because here is 11m. So we put here 6. 6 multiplied by this m, we get 6m. And here 5m multiplied by 1, we get 11m. So and 6 multiplied by 1, we get 6 here. So you can see here, if we divide this m cube plus 6m square plus 11m plus 6 by m plus 1, we get this one. You can see here, we put m plus 1, m plus 1, m plus 1 3 times. Here is m cube, so m multiplied by m square, this gives m cube. Here m square multiplied by plus 1, we get plus m square. But here is 6m square, so 5m square is less. So we multiply plus 5m by m, we get 5m square, and this is m square, we get 6m square. Now here plus 5m multiplied by plus 1, we get 5m, and here is 11m plus, so 6m is remaining, so put here plus 6. When we multiply plus 6 by m, we get 6m, and here 5m multiplied by 1, we get 5m, so total is 11m. And this 6 multiplied by 1, we get 6. Now taking common m plus 1 here, you can see this can be written as m square plus 5m plus 6 equal to 0. Now we factorize m square plus 5m plus 6 equal to 0. We get now we factorize this m square plus 5m plus 6. So this can be written as 3 plus 2m plus 6 equal to 0. Now we factorize here m square plus 5m plus 6. So this can be also written as m plus 1. Here m square plus 3m plus 2m plus 6 equal to 0. Taking common m, we get m plus 3. Here we common 2, we get m plus 3. If we take common m plus 3, we get m plus 2 equal to 0. So m is equal to minus 1, minus 2, minus 3. So these are the roots of the above auxiliary equation. And all these roots are distinct. Here, distinct roots of auxiliary equation. So the general solution can be written as y is equal to c1 e to the power m1x plus c2 e to the power m2x plus c3 e to the power m3. Here m1 is minus 1, m2 is minus 2 and m3 is minus 3. So this can be written as c1 e to the power minus x plus c2 e to the power minus 2x plus c3 e to the power minus 3x. So this is the general solution of the given third order linear differential equation with the constant coefficient where the right hand side becomes 0. Now we take another example. You can see that this is the second order linear differential equation with constant coefficient. You can see here d2y by dx2 plus p1 dy by dx plus p2y is equal to 0. This is the linear differential equation second order linear differential equation with constant coefficient. Here you can see that this is the second order linear differential equation with constant coefficient. Here the right hand side is 0. So first this equation can be written as d2 capital D2y plus a plus b capital dy plus aby is equal to 0, where capital D is equal to d by dx. Now this can be also written as d2 plus a plus b d plus aby is equal to 0. Now we find auxiliary equation. So for auxiliary equation we put m in place of d. So we get m square plus a plus b times m plus ab is equal to 0. Now this is the auxiliary equation. Now we solve this auxiliary equation and get the roots of this equation. This is the quadratic equation you can see in m. So we solve this by the factorization method. So am plus bm plus ab is equal to 0. Now we taking common m, we get m plus a. Here we taking common b, so we get also m plus a. Now we taking common m plus a, we get m plus b is equal to 0. So the roots of this auxiliary equation is minus a and minus b. These roots are distinct. So the general solution is, so the general solution is y is equal to c1 times e to the power m1x plus c2 times e to the power m2x. You can see that this is m1 and this is m2. So the general solution is c1 times e to the power minus ax plus c2 times e to the power minus bx. So this is the general solution of the given second order linear differential equation. Now we take third example. Now this is the third example. Here we have to solve this differential equation. And we know that this is the second order linear differential equation with constant coefficient. This can be written as d2x by dt2 plus p1 dx upon dt plus p2y is equal to 0. This is the linear differential equation. This is linear differential equation with constant coefficients. This is the linear differential equation with constant coefficient. So for solving this, first we write here d2x minus 3dx plus 2x equal to 0, where capital D, this is equal to d by dt. Here you can see that the above differential equation can be also written as capital d2x minus 3 capital dx plus 2x equal to 0. Now with taking common x, we get here d2 minus 3d plus 2 equal to 0. For solving this, first we find the auxiliary equation. So for finding auxiliary equation, we put m in place of capital D. So this is m square minus 3m plus 2 is equal to 0. We can see here, this is the quadratic equation in m. Now we solve this quadratic equation and get the roots of this quadratic equation. So we using here factorization, we get here 2m minus m, this is 3m and plus 2. Now taking common here m, we get m minus 2, taking common here 1, so this becomes m minus 2. So m minus 2 is common here, we get m minus 1 equal to 0. So m is equal to 1 and 2. So these are the roots of the auxiliary equation. You can see here, first we write the given differential equation in this form. In place of d2 by dt2, we put capital D square. In place of d by dt, we put capital D. And taking common here x, and this can be written as d2 minus 3d plus 2 times x equal to 0. Now we find auxiliary equation. In place of capital D, we put m. So this is m square minus 3m plus 2. We factorize this m square minus 3m plus 2. We get two distinct roots, 1 and 2. So the general solution. Is, you can see here, this x is the dependent variable here and t is the independent variable. So we can write here x equal to c1 e to the power m1t plus c2 e to the power m2t. Here x is the dependent variable, so we write here x, and t is the independent variable, so in power of e we write here t. So you can see c1 m1 is 1 here, m2 is 2 here, so x equal to c1 e to the power 1t plus c2 e to the power 2t. So this is the general solution of the given second order linear differential equation with constant coefficient. Now we differentiate this, we get dx upon dt, c1 is constant here, and differentiation of e power t with respect to t is e to the power t, and c2 is constant here, and differentiation of e to the power 2t with respect to t is 2e to the power 2t. Suppose this is second. Now we use boundary condition here. T is equal to 0, x equal to 0. When t is equal to 0, x equal to 0 and dx by dt is also 0. So put t is equal to 0, x equal to 0 in 1. We get here 0 is equal to c1 plus c2. Because e to the power 0 is 1, e to the power 2 into 0, that means e to the power 0, this is equal to 1. So, and in the left hand side, this x is 0. So, suppose this is third equation. Put t is equal to 0 and dx by dt is equal to 0 in second. So, we get here 0 is equal to c1 plus 2c2. Now, we solving these two equations, third and fourth. We get, now we solving third and fourth. So, 4, third subtract from 4, we get here c2 is equal to 0. If we put c2 is equal to 0 in third, put c2 is equal to 0 in third, we get c1 is also 0. So, the solution is x equal to 0, because in place of c1 we put 0, in place of c2 also we put 0, so we get x equal to 0. So x equal to 0 is the solution of the given differential equation. Now we take another example. Now we take another example 4. Here we have to solve this differential equation d square minus 4d plus 1y is equal to 0. So first we find here auxiliary equation. You know that if we replace, in place of capital D, we replace m, we get the auxiliary equation m square minus 4m plus 1 equal to 0. Now we find the solution of this quadratic equation, roots of this quadratic equation. So use here Sridharacharya formula. So we get this is minus 4 plus minus under root b square. So this is minus 4 square minus 4 multiplied by 1 multiplied by 1 divided by 2a. So m is equal to, this is 4 plus minus, this is 16 minus 4 divided by 2. So m is equal to 4 plus minus, this is root 12 divided by 2. So this is equal to 4 plus minus 2 root 3 upon 2. So we taking common 2 and 2 is cancelled out. So this becomes 2 plus minus root 3. Here the roots of m are 2 plus root 3 and 2 minus root 3. So first we find the auxiliary equation of the given second order linear differential equation with constant coefficient. For auxiliary equation we put m in place of capital D. So m square minus 4m plus 1 equal to 0. We can see here, this is the quadratic equation. So solving this quadratic equation by Sridharacharya formula and get the roots of this quadratic equation 2 plus root 3 and 2 minus root 3. You can see these are the distinct root. These are the distinct roots. Now we find the general solution. So the general solution of given differential equation is y is equal to c1 e to the power m1x plus c2 e to the power m2x. Here e to the power m1 is 2 plus root 3 here, and m2 is 2 minus root 3 times x. This can be also written as e to the power 2x multiplied by e to the power x root 3. Here e to the power 2x multiplied by e to the power minus x root 3. So taking common here e to the power 2x, so we get here c1 e to the power x root 3 plus c2 e to the power minus x root 3. Now, if we put c1 is equal to a plus b divided by 2 and c2 is equal to a minus b divided by 2, so this can be written as e to the power 2x, and here a plus b divided by 2 e to the power x root 3 plus a minus b divided by 2 e to the power minus x root 3. Here we put c1 is equal to a plus b divided by 2 and c2 is equal to a minus b divided by 2, and we simplify this and get the answer. So y is equal to e to the power 2x. You can see here, we can write here a times e to the power x root 3 plus e to the power minus x root 3 divided by 2 plus b times e to the power x root 3 minus e to the power minus x root 3 divided by 2. You can see that if we solve this, a by 2 multiplied by e to the power x by 3 and a by 2 multiplied by e to the power minus x by 3, we taking common a here, we get e to the power x by 3 plus e to the power minus x by 3 divided by 2. Similarly, if b by 2 multiplied by this e to the power x by 3 and this minus b by 2 multiplied by e to the power minus x by 3, so we taking common b, we get e to the power x by 3 x root 3 minus e to the power minus x root 3 divided by 2. We know that this is cos hyperbolic x, this is equal to e to the power x plus e to the power minus x divided by 2, and sin hyperbolic x can be written as e to the power x minus e to the power minus x divided by 2. So this can be also written as a cos hyperbolic x root 3 plus b sin hyperbolic x root 3. So this is the answer of given second order linear differential equation with constant coefficient. Thank you.